So our final session before lunch will be a panel about open source. Chairing the panel will be Mike Gualtieri of Forrester. We also have Martin Oberhuber?
Yeah, that's right.
Sorry.
It's okay.
From Think Big. Onkar of who's the data scientist for MapR. Sean Owen from Cloudera is rejoining us. And Kostas Tzoumas, who is the CEO of Data Artisans, a company founded here in Berlin, and one of the founders of Apache Flink. Thank you very much.
Okay, well, thank you, everyone, for coming to this session. Let's start off with a quiz. How many are using open source? Yeah, it's got to be everyone somehow, right? So I'm delighted to have 4 open source aficionados. You guys like open source, right?
Sure.
You passionate about it?
I'm paid to. Yeah.
Okay, all right, because if you're not, you're not here. So first, let me have you briefly introduce yourselves. Martin?
Yeah, sure. I'm Martin Oberhuber. I'm a senior data scientist for Think Big, which is a Teradata company, and we basically provide professional services for Hadoop systems and other open source technologies.
Okay, very good.
Sean Owen, yeah, Director of Data Science for Cloudera. We distribute Apache Hadoop and other open source technologies for big data, and our piece is to help people do machine learning and data science. So you may have seen me, if you're on the Apache Spark mailing list, you probably run into me. I work on Spark a lot.
And Onkar?
Hi, I'm Onkar Amber. I'm a data scientist with MapR. MapR is very well known as an enterprise distributor for Hadoop. We also support Spark. And data scientist, as a data scientist, I'm part of professional services. And I'm looking after the EMEA region, which is Europe, Middle East, and Africa. And yeah, we support lots of open source community, as well as we our own use open source community as well. So open source stuff, yeah, thanks.
And Kostas?
Cool, Kostas. So I am one of the people that originally created what is now the Apache Flink framework. It's an open source stream processing framework. And now in my day job, co-founder and CEO of a company that was basically spinned off from the development team of that framework based in Berlin.
And that's Apache Flink.
That is Apache Flink.
Most Apache and open source seems to get created in Silicon Valley, and Apache Flink was invented here in Germany. So let's give them a hand for that. All right, so let me start with Onkar and Sean about Hadoop and Spark, and just what is that ecosystem like? I mean, what we want to explore here is what open source options, platforms are available for data scientists from your perspective. Sean, let me start with you.
Sure. So what is Hadoop and what is Spark? That's a big question. I think if I had to boil it down, Hadoop is a collection of technologies for storing lots of data. You think HDFS, think HBase, think Yarn for managing resources. And Spark is a framework for running computations, using that resource manager, using that storage, in a distributed way at scale. So maybe respectively the OS and the application framework of the Hadoop ecosystem.
All right, so Hadoop Spark, very relevant to our
core.
conversation. Anything else that you're sort of watching or thinking about, or I call it Hadoop and friends, right? Because Hadoop has lots of friends. I would say Spark is a friend.
Right.
Maybe we'll explore whether it's a friend or a foe later, but Spark is a friend. What other things are you guys looking at Cloudera?
Sure. I think the big news this year is trying to make Python more of a first-class citizen within the Hadoop ecosystem, which has traditionally been very Java, Scala, JVM-based.
Well, let me stop you there. Is that possible? I thought Hadoop is a Java.
It very much is. So it's hard to bridge the gap between the world of Python, which is what a lot of data scientists in the room are using, and the world of Spark and so on. But we've started with things like PySpark, for example. It is possible, but it does take work. So that's what I'm looking at these days.
Cool. And Onkar, what about you? I know you guys obviously have a Hadoop distro. What do you see as the most relevant open source technologies?
So, I mean, everybody is, in big data framework, everybody is talking about Hadoop. But if you just look at Google Analytics, right, Hadoop, and then Spark, you see the number of hits per Spark are growing, and Hadoop is coming down. What it means is simply everybody is going towards Spark. But naturally, Spark can be part of Hadoop ecosystem. Right. That's how it is built. It can be standalone, but it can be part of Hadoop ecosystem. So what we are doing is basically leveraging the both worlds. The difference between, Spark is basically a computation engine to me, which is equivalent to MapReduce, but which does it everything in memory, which makes it 100 times, 10,000 times faster depending on the operations. So what it is actually is in MapR, we see the customer's requirement needs, if it's real time, if it's not so real time, if it's not so critical, we define what we need to use. But it seems that Spark is the way to go. Flink, on the other hand, is coming to the eyes of everybody, because Spark, even if everybody is saying that it can do streaming operation, in reality it's batch process, micro batching, what we call it. But Flink is actually, it does really stream processing. So that seems to be a challenge for Spark. How challenging will it be? Time will tell.
Well, Kostas, tell us about Apache Flink. What is it, and what other projects do you think are relevant to the data science community?
Yeah, so I think the premise of Flink is a little bit different. So it is a good Hadoop layer. It is one of the Hadoop friends. It runs on Hadoop.
Runs on Yarn?
It runs on Yarn.
Yeah.
You can use it for use cases that you use MapReduce or Spark for. But I think the really promising thing is the following. So if you think about data production, like way before it enters Hadoop, it usually is a continuous process. So data is generated continuously and very, very fast. And until now, have been basically putting artificial barriers in this process, so waiting for a day to put it in Hadoop and then waiting for some time to run our computation. The premise of Flink is basically running analytics on the data in motion even before it enters Hadoop. So a lot of people are doing that right now with Kafka, Apache Kafka, and then basically using streaming frameworks like Apache Flink to run analytics directly on the data in motion.
Yep. Cool. Martin, you work with enterprises, implementing data science, big data projects. What's relevant? What are enterprises adopting, and what do you recommend to them?
I would say more or less most of the enterprises that go into the field of big data or adopt big data solutions are, of course, looking at Hadoop as the first relevant component, and then all its the whole ecosystem like Hive and Spark, of course, is relevant as well. I would say Spark more recently is getting a lot of traction. Like more traditionally, over the last 5 years, Hadoop was definitely very relevant. But then it comes down to also integrating these systems with existing frameworks like data warehouses. Or other databases. So one of the big challenges that we have or we face often is to not being able to port the whole system over to Hadoop and that's it, but interfacing with these systems and working in tandem. So it's very much custom work that we do on top of these solutions. Yeah.
And a lot of you guys have mentioned sort of Hadoop and Spark, but you're not suggesting that Spark replaces Hadoop. It's complementary, right?
As I said, I see Spark as a computation engine only. It's not the complete ecosystem.
So, but okay, it's a computation engine, but Hadoop is a file system and a computation engine. But I think what we're saying here,
MapReduce is a computation engine within Hadoop.
Right, yeah. Right. And what I hear in the market is that people who normally a year ago would write a job in MapReduce, they won't do that. They'll just do it right in Spark, right?
Yeah. So what is replacing is Spark is not replacing Hadoop. Spark is replacing MapReduce.
Right.
I would say it that way.
Right. Yeah. You guys agree with that?
I would agree. I think, it's really a false choice. There is no Hadoop versus Spark. Spark, for example, has no storage, has no security model. By itself, it it's not the whole picture. But neither is Hadoop. Hadoop's actually a bunch of things, all that you could swap in and out. Spark's replacing several pieces of the ecosystem, Giraffe, maybe Mahout to some degree. But 'twas ever thus. We've always had incremental updates and new things arriving in the Hadoop ecosystem. And we never really have or should have to choose between the two. I don't even think Spark's that revolutionary. I mean, we've already not been writing MapReduce jobs and writing things in cascading or Crunch, for example. So this is all business as usual. There's not some big bang change that's going on that's a showdown between.
So natural evolution.
I think it's
the way
more
you
natural.
see it. Yep. Martin, let me go back to you on use cases.
Yep.
What are some of the key enterprise use cases that you're seeing?
So we've worked in many different domains, but broadly speaking, I would say you can categorize it within 3 groups. What we do a lot is device analytics, such as manufacturing, sensor data, Internet of Things as well, and then risk analytics relevant for banks, insurance companies, portfolio asset management companies, and so forth. And then there's the custom analytics side, which is telecommunication companies or e-commerce or retailers in general. I think all of these 3 domains generally deal with large data sets, and they have some form of need of big data solutions, whether it's on the pure engineering side, just to store the data and being able to retrieve the records that they need at certain times, or actually doing proper analytics, building machine learning models.
Okay, so talk to me a little bit more. So, because storing data is really boring to me.
Yeah.
Especially since we have Hadoop now, right? That's easy. But talk to me more about the data science, the machine learning, and specifically, are there open source tools that you use?
Yep.
Are the open source tools sophisticated enough to actually use to create predictive models, for example?
Certainly, yeah. So I would say, as a data scientist, still most of the sophisticated algorithms or machine learning approaches that one uses is still done on a single workstation in a not distributed way. What very often happens is that you use Spark or Hadoop to filter down the data, sample it down to manageable size, and then build a predictive model. It's not to say that that's always the case. Occasionally, you actually use Spark MLlib as well to actually build distributed machine learning models, but very often it comes down to pre-filtering, sampling, and pre-allowing the data so that you can use Python and R and all its powerful packages that come with it that are not yet available in a distributed way.
Right, so you
also
mentioned,
due to the complexity of
you
those
mentioned
algorithms.
Spark MLlib, which is the machine learning library. Can you guys comment on the maturity of that library? Can data scientists use that? Has a handful of algorithms, or Onkar?
So maturity level, I would go in two ways about it. One is, if I see from big data point of view, machine learning has been done, as he has said, on a single workstation. So it is a small data. And with the small data comes its own challenges of generalization of things, because you don't know the universality of the data. And that's why you created, or the community created, or the researchers created so many complicated algorithms, SVMs, neural networks, deep learning, blah, 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 the list goes on. What was not foreseen was what actually happens when you have the humongous amount of data. What happens with the generalization of the simple algorithms such as PCA. In many, many cases, it has been seen that you don't require heavily complex algorithms if you have actual big data. Your simple algorithms can have the capacity to generalize or classify these clusters pretty easily. I'm not saying that is the only solution, but I'm saying that is one of the things that you have to look into.
So it sounds like what you're saying is well, it doesn't have hundreds of algorithms, like, by the way, IBM's System ML project is embarked on.
I'll come to that point. Okay. So that was my first point of small data versus big data and what changes from machine learning. And the second point is coming to the maturity of the open source machine learning. Yes, it's not there. That's a full stop.
It's not there.
It's not there.
Okay.
Because what we have on a single node is not yet replicable on the big data open source platform as of now. But in a couple of years down the line, I don't see it's not going to happen. It will happen. We have to wait to see. Actually, I haven't came across any use case where the simple machine learning algorithms cannot be used on big data. There obviously may not be. I haven't come across. To come to deep learning algorithms, which I call a black box, nobody in this room would be able to tell what happens there. It's a complete black box, but everybody blindsidedly uses it.
Well, Spark doesn't have that.
Exactly my point, but they use deep learning 4J dot blah, blah, blah. Right. So that's another question. We have humongous amount of different sorts of machine learning.
Let me move on to another open source programming language, which seems to be quite popular among data scientists, which is R. And Sean, do you have any comment, or does anyone have any comments on R as a tool? Because what's weird to me about R is that, well, first of all, I'm a developer back in the day, and I look at that as a programming language, and I really don't like it. It's not how you design a programming language from scratch, so I have no idea why it's so popular. I think I'm answering this question. And it wasn't designed to scale, right? But there's Spark R. Can any of you comment on R as a tool?
R is a poor legacy language. As a language, it's got beautiful language.
So you agree with me?
I agree with you.
Okay.
Certainly, if you're coming at it from a lens of a systems engineer like me, coming from the world of the JVM, it's not a good language.
Yeah.
It's not meant to be a systems language.
Right.
But people use R for its libraries, and the fact that it's free and open source. They also use it for the integration of a visualization as well, the same appeal of notebooks in the Python world. Mm-hmm. So there's still a lot of value in R. It's not clear to me it can be meaningfully bridged to the big data world. It's just maybe a bridge too far, if you will. Spark R notwithstanding, it's really two very different worlds to bridge. I'm a little bit skeptical.
Yep. And Kostas, let me ask you about other programming models, like whether it's an Apache Flink or Spark. I mean, what is the programming model, the ideal programming model to get to either process data or do machine learning?
Right. So I really think it depends on what you want to do. So I'm not a machine learning guy, so by what machine learning guys tell me is that the model that they think of is much higher level than if you look at Flink or Spark or whatever. So they want to think in terms of algorithms, in terms of pipelines, really, that include feature selection, include the algorithm that you choose to do basically the machine learning, cross-validation, and so on. So I think that's a very different thing. If you look at broader use cases beyond machine learning, so old-fashioned data crunching, I think we're sort of converging to a model. So if you look at the open source frameworks out there, they kind of have a similar model. From a Flink perspective, what we see as the next step is integrating into the programming model the notion of time. So until now, you don't know how old your data is. You don't know when this data was created, but really the value of a data item is very closely associated to when it was created. Mm-hmm. So making that very explicit and putting that in the programming model is really, I think, the next step for analytics. Yeah. And that's something that we've been working a lot on with Flink, and a couple of other projects have been doing that. In particular, Google Cloud Dataflow has been doing that as well.
Let me ask you guys about commercial software and open source. And Martin, what's your perspective on that? I mean, can a company seek to do everything in open source? When do they need to consider commercial software? And a lot of the Hadoop distros, I'll get to you guys, offer value add on top of the pure distro. But Martin, how do you think about that?
So personally, I'm a big fan of open source, especially in the data science field, and particular R, actually, so I'm a big fan of R, even though I agree with you on the programming model.
Yep.
In terms of enterprises, I would say, yes, you could do everything with R and Python and maybe some graphical tools or dashboarding tools. But as a matter of fact, most enterprises are not there yet. Many have, still systems like SAS in place, SPSS, and so forth. And we are not really trying to convince them that they should go away from those tools and go.
Well, those tools actually
source.
Have versions which can use those platforms too.
Yes, that's a good point. My take on open source in general is you always find the newest technology there. The enterprise solutions are sometimes a little bit lacking in terms of what solutions are available. For instance, in R, when you read a new research paper or anything or so, there's a good chance that somebody already implemented that algorithm in form of a package or so, which is not necessarily the case for commercial solutions all the time.
Yeah. Yep. And Sean, I know Cloudera has one of the 3 pure play distros, right? And you have an enterprise that has some commercial licensed on top of your distro. How do you guys make decisions about what is in the open source versus what you guys add value to as commercial?
Right. There's nothing wrong with closed source or commercial or proprietary software. I think, although it's probably generally agreed that we no longer accept that in the core. We don't want closed data formats, closed storage, closed compute. Tools around that, maybe so. That seems a lot more legitimate. There's still a market for open source software in the core. It's just that people want support, not to pay you for the software. I think that might change a little bit when we talk about analytics tools. It's not as imperative that you have an open source analytics tool, although that's nice. So I think there's still a market for proprietary analytics software connecting to an open core of storage and compute. Witness SAS, for example, still going strong, can connect to Hadoop, and just doing fine.
Mm-hmm.
Yeah.
And Onkar.
Yeah, I mean, I would agree with Sean. The distro part, there is a lot of open source. Everybody wants open source. But when it comes to enterprise, they still want support. And when you go to pure open source distro, it becomes difficult. So that's where Cloudera, MapR, some other companies come in picture, where we have a lot of good resources to support. We have, like, maybe everybody knows MapRDB, which is based on HBase, but we have created very efficient HBase, which is MapRDB. So it's not a typical HBase that you have in your distro. So we use what is open source, we enhance it, and then we create licenses out of it. So that's one part of it. Coming to data science, yes, there are a couple of open source, but as I said, maturity level is, I would put it 0, but it will go, it will increase.
How do you guys figure out, how does anyone figure out which open source to use? So for example, Hortonworks is pushing Apache Ranger and Embari, right? You have Cloudera Manager, use Sentry and the security solution. You have Apache Drill. That can be very confusing. Kostas wants to comment on this.
Yeah, so I think there's another dimension, right? So Ted Dunning from MapR says that open source has actually 2 dimensions. It's open code and open community, right? And if you look at the core, so I completely agree with Sean, by the way. If you look at the core, you're going to see these big projects with a lot of contributors, so really open code, open community. If you start looking around the edges, you're going to see a lot of projects that have open code, but they are tightly controlled by a company, or the community is very small. I mean, this you can sort of allow them to be closed source as well. It's not going to make such a huge difference. And this is basically, it comes from the nature of the functionality of the tool itself. So if you can achieve a broad, open, big community, then there's a lot of value in the open source. If you're going to end up doing the same thing and just the code is open, then you can do it closed as well.
I just wanted to add one point. So if, in terms of open source, community migrates, like Mahout, community is getting...
Mahout's the machine learning library that was originally ran on Hadoop, but now they're pushing it on Spark. Yeah.
So everybody from that community is migrating to mlib from Spark.
Yeah.
So there are positive sides and negative sides of open source. And this, when it comes to enterprise distros like MapR or Cloudera, we have to be careful in that sense to have that vision to know what is going where and when we have to stop it or when we have to support it.
Now, one of you mentioned, I don't know if it was you, Sean, or Martin, but this is for all of you, innovation. Does innovation, generally people say innovation is faster in the open source community. I'm not so sure that that's always true. I mean, I see 3 companies, Hortonworks, MapR, and Cloudera, really sort of accelerating that. In some cases through the open source community, in some cases, filling enterprise gaps that the community isn't even aware of these enterprise gaps, right? But you guys are, because you're on the street in the enterprises. So I'd like any of you to comment on that. Martin, do you have any thoughts on that?
Yeah, as you say, I think it's very important for other enterprises to support the open source community. Just the open source community wouldn't probably be able to tackle all the business problems that commercial solutions would require. So I think it's definitely worthwhile pointing out that a mix of both is good. The open source community alone would probably not be enough to meet the goals of enterprise in terms of innovation. Yeah, I think so.
Sean?
The premise is that open source has far lower barriers to entry for a new good idea, and that's true. But that's not all that we need for innovation. I think you'll find that an open source project isn't actually literally random people submitting random patches at each other. There is some subset of people driving a vision in that project, and so I think there is a place for direction and oversight. And so sometimes an organization that's trying to build a market out of it has that incentive and can usefully provide direction to take raw ideas and fashion them into something usable in the market. And that's innovation. So yes, I think commercial entities do have an important role to play in open source.
Because when I think of Cloudera and MapR, I think of two examples of that. So, Hive wasn't really designed for interactive query, right? So Cloudera came up with Impala, which I know is open source, not Apache. Managing a Hadoop cluster was the command line. You came up with Navigator. MapR, the HDFS file system is pretty lame, really, when you think about it from a file system. So you sort of rejigged that with an HDFS interface. So I think there's a lot of examples of where the commercial companies are pulling.
I would say in this case, innovation is happening at two ends. One is understanding the needs of enterprise and catering to that. There is also innovation there, and another is this open source community. The open source community doesn't really cater to or think about or envision about the needs of IoT, the needs of fintech, the needs of any other industry verticals that we can think of. They don't cater to that vision. They cater to the technology vision. Mm-hmm. But as a company, as an enterprise distro company, we have to cater to the vision of those verticals. We have to cater to the vision and the needs of those verticals. And we have to foresee them. We have to work on that. And that's where these three big names are still existing.
And Kostas, I want to hear from you, because you formed a company.
That's right.
Data Artisans, that's sort of the equivalent for Flink as the Hadoop companies. What are you trying to do?
Yeah.
And how are you balancing the open source and your goals as a company?
Yeah. So just to comment on that, I think open source is great. So before even I founded Data Artisans, I was a database systems researcher. And we should remember that a lot of innovation actually comes from universities, right? Mm-hmm. And there was a time in database research where, as a researcher, the best thing you could hope for is Microsoft and IBM picking up an idea that you had. Open source really changed that. So Spark came out of university research, Flink came out of university research. So in that sense, open source actually does make a difference, and it does accelerate innovation. Now, how do you balance company and open source? I think it's not so hard as people think. So open source is here to stay. I don't think anybody wants to use a proprietary closed source platform down at the bottom. And it's just a matter of supporting your users, making sure that they have someone to talk to, providing value-added products on top of that. But I think the secret sauce is basically the division of functionality between what should be open source and what we can provide as proprietary.
Yeah, and I mean, certainly, when it comes to Hadoop and friends, the enterprise company, the largest enterprise in the world, we did a recent survey that showed like 54% adoption, but we estimate at Forrester there'll be 100% adoption of these frameworks, and that doesn't sound crazy because there's 100% adoption of an RDBMS, there's 100% adoption of web servers, right? There's certain technologies that are so core and fundamental that every enterprise will have it, and I think Hadoop and Spark meet that. But I wanted to also ask you about Apache, the Apache Foundation, because that's probably the most prominent open source community. Is that the only community? Is that the only way to go? Sean?
Boy.
Martin? Sean? Anyone?
I'm sighing just because I have strong thoughts about the ASF. What's good about Apache? The license has proved a good open source license. The community process, that's proved durable. as an entity, as a neutral ground and a legal entity in which to collaborate, that's worked well. However, that doesn't have to, that could be duplicated anywhere, really. It's not specific to the ASF. And in fact, I wonder if there's been an excessive fascination, so to speak, with the brand. People now believe that an Apache X means official, adopted, community standard, which it doesn't actually mean. And that's been, I think, turned around, unfortunately, and almost it's become a means in itself to become an Apache project to get some of that halo effect, which has corrupted some of the things that are good about Apache and the ASF, in my view.
Yeah, and I think people do think it's some sort of brand of products that were designed, but that's not how you become an Apache project. How did you become an Apache project, Kostas? What did you have to go through?
So people have a very wrong idea of what the Apache Software Foundation is, right? So it's mainly a loose connection of communities of people, more than someone that says, hey, here's a stack that you should be using. So the Apache Software Foundation does not produce software, if you wish. Yeah? It provides a blueprint for a community, for an open source community to grow. In my personal experience, it does help a lot. So if you have a young open source project, you're going to have to discover many things and many rules. The ASF gives you, a certain restriction. These are the rules that you're going to be following. These are the processes, which actually does help because, if you were just doing that alone, you would probably end up on the same thing, basically rediscovering the wheel. So it does save you time.
Yep. Guys, we're out of time. So I'm going to ask you all one final question. What advice you would have for an enterprise or for anyone who is adopting open source for big data? Martin, let me start with you.
I would say start small and then scale fast.
Well, start small. How many nodes?
Well, I would say it's more in terms of identifying use cases.
Yeah.
Like most of the companies or enterprises, they have many use cases. They have hundreds of data sources, and it's not feasible to convert the whole system from, say, a traditional data warehouse to a big data Hadoop platform, and then just flip on a switch and hope everything goes well. So I would definitely say identify a few use cases, maybe one or two or a few more, and implement those and make sure that they run smoothly in production, and then scale from there. Because while you do that, you can iron out the issues that you run into with those small use cases, and then don't repeat them again when you build the whole system.
Very good. Thank you, Martin. Sean?
Think about your data. The software is free, the hardware is cheap. Data is not something you can just gin up out of thin air. So maybe think about your strategy in terms of the data you have or you want to have, and start collecting it now, because you can't go back in time and collect it at post hoc.
Thanks, Sean. Onkar?
I agree with both of them, but the third point is go with MapR.
Go with that.
Go with MapR,
Yeah.
Right. So I would say there's a lot of choices out there right now, and it might be hard sometimes. If I had to basically say one thing is do a POC, do a proof of concept. Don't base your decisions on hype or comparison charts that you find on the internet. Do a minimal POC, evaluate what is out there, and choose based on that.
Thank you, Kostas. Martin Oberhuber, Sean Owen, Onkar Amber, and Kostas Tzoumas. Thank you very much.
Thank you.
Thanks.
Thanks.
Thank you.
Thanks.